Elad, hardware companies are notoriously capital intensive and face long sales cycles. How did you navigate these challenges when you were building Next Silicon?
So first of all, Barak, thank you for having me and hosting me. It's a pleasure to be here. I'm excited about this podcast and this recording, and I hope to share some of my experience with all the founders going to F2, and great fun to be at, and great place to be. So let's break up this question into smaller pieces, if I may, because the first question is capital and capital expenses, and that's huge. In any company, the most important thing is money in the bank, right? How much runway do I have? How I utilize that spend? And the most important thing is obviously to get revenues from the end customers. But if you can do that, you sell some equity, right? So that's just the reality. And Silicon is way, way more, as you mentioned, notorious when they're doing the spend. Back in the day when more scale was at the beginning, you can easily go and tape out. Tape out is the meaning of doing the silicon fabrication at some foundries. Most important and known one is obviously TSMC in Taiwan, Taiwan Semiconductor Manufacturing Corporation, and there are many other, UMC, Global Foundry, and more. But today, just the cost of making the mask on the wafer, on doing the manufacturing, that's almost a $10 million in the low end. And when you go to 3 or 2 nanometer without revealing numbers, it's somewhere between $20 to $30 million. Okay? And that doesn't give you lots of silicon, a lot of computing chip. That just gives you the mask and the ability to produce more. Each one of them can cost a BOM cost of thousands, and you have high bandwidth memory. And just manufacturing 100 units. Yeah, just the fun part in our second generation, just to manufacture 100 chips. Not the initial investment is almost like a seed investment in some companies. Okay. Add to that the fact that you need 3 years to plan the chip because the cost of silicon malfunction is to pay this another $20 million again. So you want to make sure that everything works, and software and hardware, you get easily to $130 million, $160 million when you're going to advanced nodes. That's insane. So you need to be very thoughtful and very diligent in the go-to-market, how you are operating. And the other flip coin is, to understand that at least with compute market, this is what we do Next Silicon. Yes, we are developing next generation compute. Those are the computing chip that you see here. And when you go to compute market, the end game is huge. Like none of the compute companies hoping to be acquired at $100, $200 million, which is the amount of investment that you need to get just to the go to market, right? But if you win that market, you can get dozens of billion of dollar market cap, hundreds, $1 trillion market cap. Why? Because that's a very binary outcome. Okay, so lots of investors, the way that they see it, at least in the first years of the company, is not ARR. I mean, that's nearly not exist in semiconductor companies, not on revenues multipliers, but on technology roadmap and how you can go to market. The other thing that you need to understand is, and be diligent, is the go to market. Okay, you have public companies, you have private companies. Those behave completely different between the public sector and the private sector. Private sector, the mission statement is to find oil and gas, to find the new drug. I mean, to build their own rocket. They don't care about building compute. So you need to be in production phase. Being in production phase, that's the second generation. That's another $150 million of investment. Okay?
Wow.
just to get it, because you never hit everything on your first try. For example, customer will want a secure boot, okay, with their own keys, and you forgot to put it in the first generation and more. And then you have the public sector. So you need to understand who can pay for your product first and how you can generate the first revenues. That's important, because once you have this proof point, then you have a co-design, you have a customer that steer you from your, even before the first generation, towards future generation. So, complicated question, long answer,
It
apologize
goes
about
back
it.
to where you started, though. It's a combination of some equity financing, but to the extent possible, use your customers to finance these initial stages. Is that right? What did your seed round look like?
We raised in the seed round $5 million.
Okay.
And then the hardest fundraising that I have was not the seed, but the A round, which was $26 million. Why? Because you have proof point, you have customers that say, hey, you know what, we want that. We pay you pre-orders. Okay, we had that. Actually, we didn't have the actual revenues yet. That was immediately after the A round, but we had to convince investors, hey, you need to put $25 million to allow us to get to tape out. This is our novel architecture. That's a roadmap, but lots of capital, may fail. So that was the hardest one. And, no matter how you flip it, your customers, at least your early adopters, will not finance your company, but they can show investors that, hey, we have here an opportunity. In 2024, 2025, 2026 timeframe, it can be $200 million computer. Okay? So roadmap and technology is important, at least until you're able to secure hundreds of millions of dollars on investment, and then you can execute on your plan.
Got it. So when you were pitching that first 5 million or the second 20, 25 million, what was special about Next Silicon? What was your competitive advantage that you portrayed to the investors to give them conviction?
So it took me over time, and you have met many founders, right? They give their first pitch, horrible, disaster. And then the second one, until they understand why they are different. With us, we always say that we are a binary outcome, okay? We always say that we are the next generation compute. Either it's a complete disaster or it's the next big thing, okay? So that was very pivotal, and it was very appealing because you need to justify to invest in companies and see 10x, 20x multiply in a few years in the leap of faith or nothing. Otherwise, the mean value doesn't make sense, right? And with us, we never try to do more of the same. Many compute companies said, I'm going to build a better CPU. I'm going to build a better GPU. I'm going to do a tailor-made chip just for the AI machine learning and just for computer vision classification because everyone uses that, but failed to forget that in a few years you have transformers and LLM. So we said, hey, we are general purpose chip, which means that we can run anything. We can run transformers, CNN, we can run future neural network models, we can run HPC workload, and the other thing that we have said, it's all about software. Okay, all the other companies that exist up until today, everyone had a fixed hardware. This is my chip, and inside the chip, those are the functions that I can run. Try to program it. And with us, we said, let's pivot into this software play, into a runtime algorithm that understand what's going on, understand how the application behave, what's matter, what's less matter. So we speak in terms of flows, which flows matter the most, and then we try to optimize what's run the majority of the time. So it's a different play, Baruch Hashem, with God's help, now we have all the proof point and we start executing on the plan. So it's an exciting period for us. And one thing that I want to circle back about negate the challenges of fundraising, that's mostly related to the go-to-market. We decided to go to the high-performance computing market. Most of you never heard about that. Luckily for me, I've been in Mellanox. Mellanox acquired my previous company, so I know that. A huge market, $500 million machine running science and answering, everything that is important from the way that the universe was born and how drug is being discovered. And it's dominated evenly between the public sector and the private sector. Lots of companies went to AI and machine learning chip, dedicated one. And the problem there was not just that you had to spend this $300 million for multi-generation ones. You need to be in such a high maturity that someone will look at you. Plus, everyone tried to build their own chip. So it was very crowded market, very crowded space. All the hyperscalers, Google has their own TPU, and I don't know how many of you know, but AWS has their own inference chip and training chip, and Facebook is doing their own chip, Meta, sorry, and Microsoft is doing their own chip. So it's like very, very crowded market to generate the first market demand. But again, it's huge, and we said let's conquer the HPC first. AI essentially is just a neural network which build of MLOps. Those are linear algebra subroutine. No one in our lifetime, so many people afraid of basic algebra, right? Linear algebra.
Yeah.
But the HPC is way more than that. So you excel in that, understand how the MLOps behave, and then go to the AI machine learning play. So that was always from the seed deck. We always said HPC 2 generation. We always said that HPC 2 generation, 3rd generation AI machine learning.
It's like you looked into the crystal ball and it all came true. So how did generative AI alter the competitive landscape for chip companies?
A great question. And, let's talk about AI. In 1960, backpropagation was invented. People did the OCR, right? Worked. And then it was the AI winter. Many reasons until 2012 with the AlexNet and image recognition, and then ask why this huge period of time. Answer is compute. Okay. When you have a neural network that the number of floating point operation that you need to calculate it is like 9 billion, but you're running on a megahertz processor, even the Raspberry Pi that costs $10 now can run in a few gigahertz and multiple cores. That means almost an hour to run today classification, and you need like 300 megabytes of memory, or just for the weight. So we had this winter, and now people understand how compute works. And accelerated compute always started with HPC. That's like the Nvidia game. And now you have many of those compute, and you can run tera operation and peta operation in FP16. So the model became more complicated. But the funny part is that we are only at the beginning. And everyone needs to understand that. Why? Because everything that you look from ChatGPT and Midjourney and DALL-E and all the other generative AI that are out there, those are just foundation model. Give me an input, I will do my own magic, I will give you an output. Forget about training and fine-tuning. That doesn't matter, okay? But this is just a block. And then you need to go to ChatGPT, or I need to go to Midjourney, to the Discord, and I'm doing my prompt, and that's it. But we are now at the beginning. I mean, the gold wave is not the foundation model. Like I predict that ChatGPT has their own advantage, but essentially they are highly focused on the model and doing API to the model. But if someone, and if ChatGPT will not do that, will do the Linux, the Red Hat of the world with vector database. What is vector database? It means that I'm taking all the organization knowledge, all the enterprise knowledge, with all the access control, feed it, to make it, convert it to the embedding with the access control, and put it inside the database, which can then the neural network can call it with the permission, and you can, inference on-prem, remote, doesn't really matter, and give you an output. Then we'll start seeing what the future holds. And that's, way more exciting, because in vector search, you can bring a lot of data. It's like Google. You bring a lot of data to the network, crunch it, process it, just the window that matters. And, I'm not a science fiction guy. I'm a software engineer and I know lots of compute. But it's going to be an exciting period, at least. It's
You
not
mentioned
about the PyTorch, okay?
clear. You mentioned Nvidia, so their dominance in the AI acceleration market reminds us of Intel's 95% market share in the server industry. What opportunities do you see for startups in the AI infrastructure layer?
All right, good. Let's do a quick analysis about history and why Nvidia is $1 trillion and AMD suppresses Intel. And the answer is around not just being market leader, but also innovative and being flexible. So Nvidia had a good run. I mean, they were struggling. They had a graphic one. They moved to HPC. But we are now at a point that Nvidia GPU is so great, not just in the hardware, but also the software ecosystem. So you have this domain-specific language, which we said that, that's the worst thing that can happen because no one wants to program and become vendor lock. But Nvidia became, and it's a singularity point, that CUDA is de facto programmable language for accelerated compute. Okay. Nvidia smartly invested in academia, invested $1 billion every year on the software framework. That's just not just the CUDA, but also the libraries, the cuDNN for the neural network, or cuSparsity, and cuBLAS for the linear algebra. So invested so much, and people can utilize that and run their own science and neural network and more. And all the other companies said, okay, you know what? We have a chip. It's better than NVIDIA. It has more floating point units. You remember the 9 billion. Mm-hmm. Now it's like for a single token on LLM in Llama 2, 70 billion parameters, when the context, input context is just 26 token. It's like nearly, 15 words. Okay. Something like that. You need 300 trillion floating point. Just to get one token, it's like half a word, and you need lots of token to that. Lots of data. So say, okay, we have beta flow of information, but then the users say, okay, you know what? You made me a chip for transformer. Now we are in, I don't know what the next word will be. Like, again, I'm not a neural network expert, but I'm there. So I predict, and again, prophecy is given to the fool. AMD also have this general purpose one, and their hardware, although 2 years behind in software and hardware, is kind of great. So they will take 20% of the market. Regarding startup, just don't do another CPU or GPU. Think about something else that you are unique at.
Any other advice for founders innovating in this space? If you were to start over today with a mandate to form a big company, how would you tackle
it? I wouldn't make a silicon. Like, I'm a software engineer. First time that I'm doing chip, I did like 2 generation. It's, the amount of pain that you need to suffer, it's just huge. But again, if you into that, and let me take it into a generic answer, which will anywhere. First thing, choose your team right. Everyone failed in that, even us. Okay, like it took us a lot of time to go from 3 people to 10 people and 20 people in a year. Okay, because those are the people who will stay until, like, in the good time or bad time, and they will steer the company. Especially when you're doing deep tech. Like in deep tech, you can, it's very easy to go wrong to other directions. Mm-hmm. It's very easy, okay? So you need someone who will not get lost in the process. Like, the cost of mistake is higher than, I don't know, storage company that they have their own theme. I'm doing block storage, I'm doing file system, I'm doing object storage. There is just a book how to make it. So team is way important in deep tech company. You need the innovation. It's not about a better CPU and GPU. As I said, look for something that never existed today. Ask yourself why. Why no one have done it. If you will hear that many tried and failed, don't go there. If you will hear, it's simple, I don't know why no one thought about it, that's a winner, okay?
Yeah.
And runtime software that changed the hardware, people say it makes sense, but no one went there because it's like too disciplined. You have the software engineer knowing compilers, the hardware that know how to run instruction per clock. So innovation matters and the story matters. And think about the go-to-market, de-risk the go-to-market. It's like, I said that 5 times, and I will keep saying that. Think who your first customers and, just laser focus there. Listen to what makes sense, if you can justify it.
Wonderful. Elad, I think that's perfect. And this is going to be invaluable to founders out there, both knowing where to aim and what to avoid. So thank you so much for doing this with us, and we'll spread the wisdom.
Thank you very much.